transfer the concentrate by rail to a smelter facility. Here it goes into several large beds. Each one is the size of 2 basketball courts. They add silica sand, creating a layer cake of sand and copper concentrate. The silica sand is known as a flux. It will serve as a purifying agent as the concentrate is smelted. In the intense heat of the furnace, the silica sand melts to form a slag that absorbs the iron and other unwanted minerals. The slag floats up and the copper sinks. Its purity is now 60%. Then it's into a second furnace, where they up the copper content to 98%. With the copper now extracted from the ore, they pour the residue onto a heap. This molten slag flows down like lava from a volcano. As it cools, it becomes part of the landscape. Meanwhile, in the smelter, a crane delivers the fiery liquid copper into another furnace for further purification. Inside this furnace, the purity level increases from 98% to 99.4%. The molten copper flows out of the furnace and into rotating molds. The molds shape the copper into big rectangular slabs called anodes. The slabs will serve as positively charged electrodes in the electro-refining process that's still to come. That process will take the purity level up one last notch. The copper begins to cool in the molds. A sprayer douses them with water to speed the cooling process, and the copper hardens into the anode shape. A hydraulic cylinder pops them out of the molds. Then a carrier system retrieves them and takes them for a rinse. This gets rid of any traces of a non-stick substance applied to the molds earlier for easy release of the copper slabs. Hooks formed during the molding make it easy to rack up the slabs for shipment. At the refinery, the copper slabs shed any lingering impurities in this tank, as an electrical current is applied. The current causes the copper to gravitate to thin starter sheets. The impurities fall to the bottom. The copper deposited on the starter sheets is 99.99% pure, the purity level required by wire manufacturers. They load it into a furnace that's essentially a tall shaft. Midway down, the pure copper melts and flows to the bottom of the furnace. From there, they transfer it to an insulated metal channel, which keeps it molten as it now travels into a vertical mold. This mold shapes it into rectangular forms known as copper cakes. Copper cakes are used for manufacturing things like copper sheeting and plumbing parts. Fresh from the mold, the copper cakes are roughly 6 meters long. A conveyor serves them up to a circular saw that slices them to lengths required by the customer. Stacked and labeled, this pure copper cake is now ready to ship to the manufacturer. They also process pure copper into rods, a form more suitable for manufacturing electrical wiring. Molten copper moves through an opening in a mold, and, cooled by water, the copper forms a continuous rectangular bar. These grooved rollers will now take it from rectangular to round and reduce the diameter substantially. As the copper travels through the grooves, it becomes an 8 millimeter thick copper rod. The rod exits and the machine loops it into coils. They land neatly onto a steel spool. Machinery compresses the copper coil, squeezing it down so it will take up less space when it's transported. There's one last squeeze from an overhead press. and an employee ties the tightly coiled copper with extra strong plastic banding. From the Earth's crust to the factory floor, it's been quite a journey. Shipped to manufacturers, it will now be drawn into electrical wiring, and the future is sure to be high voltage.